So you're here because you want to know how to get a 10 out of 10 on the Physics IA1, which is the data test. So following on from my IA2 and IA3 videos last year, I thought I would make some data test videos as well. So if you like this one, please like and subscribe and put in the comments if there's anything else you'd like to see. Now, I just want to do a quick disclaimer. So everything in this video is based on my experience with what I did with my teachers. It's also from a 2023 perspective. So this did happen not last year, but the year before. So that was my experience. And I also can't control how other teachers write and mark their exams. So I'm just going to start screen recording my laptop because then you'll be able to see a bunch of stuff on there as well. So the problem with data tests is that they're like individual exams for you to do. So it's difficult for me to step it through because obviously not everyone is going to have the same exam, whereas we all sort of have the same student experiment, the same research investigation. Now, exams are much more variable than assignments, but I can still help out and give you some tips. So I'm just going to bring up my pen on here and get going. So what sort of things can you expect? So for these data tests, you really do need to think about what you've actually learned in class and how many topics you've done that can give you data. So for the physics data test, you should expect minimum one data test set on gravity and motion and then one on electromagnetism, and then you'll probably have a third which could be on either, or maybe they'll try and mix it or something, but that would be very, very, very mean. So in the data test, you will have a set of data and then you'll have 3 to 4 questions following it up. Now, most data tests are only about 21 or 22 marks, and then it converts it to a mark out of 10 for you. So I believe if you get above 90%, you get a 10 out of 10. So you actually don't have to get everything right to get a 10 out of 10. So that is something to keep in mind, but don't let it influence you in any way, and don't let you get lazy or anything like that. That's just because, to get 90% or above, you can only lose like 1 or 2 marks. So you still can really not lose anything to still get that 10 out of 10. Now, for the Physics IA1 for Year 12, here are the following topics that you will likely will be getting. So you could get a projectile motion, whether that's horizontal or just regular projectile motion. You could get inclined planes and circular motion. So that's sort of like part of your motion, and the other part of the motion is the gravity, so that would be Newton's law of gravity. And then the electromagnetism, things that you could be looking at is Coulomb's law, the force between magnets, the force on a Maya, and then magnetic field strength in a solenoid. So those are probably the things that you are most likely to get. Just keep in mind, the IA1 is usually like at the end of first term or beginning of second term, so you definitely won't have learned everything in Unit 3. Be sensible about it. If your teacher hasn't taught it to you, then it's probably not going to be in the data test. Now, there are a couple of ways that you can find some resources to practice for the data test, because when it comes to exams, practice, practice, practice is basically the only thing you can do to make sure that you really guarantee yourself to score well. Now, the QCE Discord server has literally heaps of stuff you can use. So when you go into the physics useful resources and then click on practice exams, it takes you to a Google Drive, and in that Google Drive, there's a folder for data tests, and there are heaps of stuff in there from different textbooks, different schools, worksheets teachers have given out. So if you head into the QCE Discord server, there is genuinely so much stuff out there. So I would definitely recommend joining up. I'll leave the link in the description and I'll pin the comment as well, because it did get taken down, but now there is a new server. So you can still join that. Heaps and heaps of resources in there, and the even better thing is you can upload photos of whatever you're doing, whatever you're struggling with, and then everyone can help you out. So it is super good like that. The other thing that you can do if maybe you don't have Discord, you don't want to get it, or you're just worried in general. Now, this is something my friends and I did as a group. So we went through our textbook and we found every single question that had data in it. So any graph, any set of data that we could find anywhere within the topics that we've done. And we ignore the questions that come along with it. Normally they're rubbish, especially in the textbooks we use. So ignore the actual questions, just take the data. Then you band up with your friends and you make a Google Doc and you paste every single graph and bit of data in there. And then you can also use ones from experiments you did in class as well. So whether that was data you collected or data you were given in experiment worksheets, anything like that. You can then write questions for the data set that you've made. So this could be 20 different sets of data in here. You could write questions for them based on similar ones from previous data tests from your teacher or the QCAA data sets or anything like that. You can then do the fake data test all together and mark each other's. I do have a massive document of one of these fake data tests that my friends and I made in 2023. So if you need it, I can upload that in the QCE Discord server. So just let me know in the comments or message me on Discord. That's the other thing. If you do want a way to contact me outside of comments and outside of emails, if you join the QCE Discord server, you'll find me like in there somewhere. Like my username is Imogen K, so you can always DM me in there as well. But yes, so that is also another option of where you can find practice. Now, I do have a list of things at the end of this video, which you should definitely stick around for, because they're sort of basically like all of the questions you could get or all the things that they could ask you. So I would stick around to that. Now, I do have a couple of little things that you should remember when it comes to actually sitting your data test. First of all, show you're working no matter what, even if you think there are no marks associated. So I'll tell you an example from my specialist IA2 in year 11 or something. I don't know. My first ever specialist exam all the way back in year 11, there was this one proof question and it was like really, really hard and none of us were getting it. And it was like a star, like it was like the shape of a star. And then we had to draw like vectors and all that. And we were all like getting so confused. We could not do this. And most of us actually got a mark because we'd drawn a circle around the outline of a star. And we actually got a mark for that because it showed that we like sort of we understood where it was meant to be going. So we did actually get a mark for that. So you should always show you're working no matter what. Even if you think that there are no marks associated, there's a good chance that there might be. The other thing is to also use your units always, even if you think that they aren't necessary. A lot of the time they aren't in data tests, but just make sure you are using units anyway because they might be worth a mark, you don't know. The other thing is to also make sure that you pay attention to the unit. So you might get a graph and you might think when you're talking about planets, because obviously planets are very big, they're very far away, you might think that the axis is in meters, but they might actually put the axes in kilometers. And then you would have to do the conversion, otherwise the formula wouldn't work. So that is definitely another thing to remember with your units. Pay attention to what they actually are. And when it comes to the formulas, make sure that you are putting the correct units in the formula. So if it's in kilometers, you're going to have to convert it to meters. So make sure that you are always, always, always reading the unit axes. The last thing is whenever you see something like use evidence from the table, you need to actually use numerical values from the table or from the graph or whatever and include it in your answer. So you can't just make stuff up. You can't put it in words or something. Like, yes, doing it in words is sort of all right. But I really do recommend when they tell you to use evidence from the table, take numerical values out, put it into a formula, put it into something, and then whatever you find based on that, also rewrite it in words, just so you've got two instances of using the same evidence, just so you've got a word example and a numerical example, just so that they can't mark you down for anything dumb like that. In your exams, whether it's your externals or your IAs, any single exam you have, I always recommend leaving as little as possible to their imagination. Tell them every single thing that goes through your mind. Write down every single bit of your working, and if it's wrong, cross it out, but write down everything because that leaves no gaps or no gray area where your teacher could be like, well, actually, no. We want to avoid that. So make sure that you're trying to put in as much information as you can to avoid your teacher trying to, like, I don't know, take marks off you for something that they really shouldn't. Now, I do have a quick list of formulas here. You can just find these in your formula book, but these are the ones that will be relevant. Now, there will be ones at the end of this electromagnetism here, so probably like that maybe, or maybe that. Honestly, I can't remember. It's been a long time, but those back-end ones in the electromagnetism you likely won't have to use in the data test just because you probably haven't learned them yet. So don't worry about probably these ones. And it's really just all of these that you should be looking at. There are also, I forgot to include a screenshot, but don't forget about the constants a couple of pages further down in the formula book. So you will need some constants, especially for G here. So you will need to know the constant for that. And mu0, you will also need to know the constant for that. They are all in the formula book, so you don't need to worry about anything like that. Now, as I said before, depending on when you're sitting on your data test and what you've learned at this point, technically all of those formulas could be on there, but please be realistic. If you haven't learned it in class, it's not going to be on your data test. If it hasn't been on the practice data test that your teachers have given you, like that topic as a whole, it's probably not going to be on there. So please be smart about it and don't try and teach yourself things that you haven't actually learned in class because it's not going to go well and you're not going to need it anyway. Another super random thing, I'm so sorry, this video is really out of order, but it's sort of the way it is with exams. Typically in these question sets, so when you get your graph, the questions initially will be super simple. They'll be like 1 mark, calculate the mean, 1 mark, literally put this into a formula, spit it out. And then they'll slowly get harder and harder. And then the last question in the question set is usually like a 3 or 4 mark, pretty complex one. And I will tell you about all the different things that they can ask you about. Now, I do have some skills here that you should know them. So first of all, a really big one is uncertainty and error. So in your year 11 data test, you probably didn't have to deal with uncertainty and error. I know it's something that was definitely introduced to us properly in year 12. Like obviously we knew what it was in year 11, but we weren't expected to use it. In your physics data test though, it will be a big thing because you're basically guaranteed to get a question about making a maximum and minimum trend line, or like, and then using like stating like the regular trend line with uncertainty based on that. So you definitely do need to know that. I have included 2 formulas here, the percentage uncertainty and the percentage error. Now, the really annoying thing about the percentage uncertainty is the formula is absolute uncertainty over measurement times 100. That's nice and all, but they don't actually give us the formula for absolute uncertainty. So that's something that you will have to remember because it isn't in your formula book. But please remember that absolute uncertainty is max minus min divided by 2, and then you put the absolute bars on it. So it will always be a positive number when you find the absolute uncertainty. But yeah, the uncertainty formula, the max number, subtract the minimum number divided by 2. The other thing that I do want to touch on that I did see in the QCE Discord server that there was confusion over it. Make sure you put the absolute bars on at the end. So do all of the calculation with the negative numbers or whatever, and then at your very, very final answer, then you put the uncertainty bars on at the end to make it positive. So it was something like this. We had like negative 0.005 subtract negative 0.002, which comes to negative 0.005 plus 0.002, and then that came to negative 0.003, and then you stick the absolute uncertainty bars on, so you get an absolute uncertainty of 0.003. Now, the problem was some people were doing it like this. They stuck the absolute uncertainty bars on first. So then they just did 0.005, so they made that positive, and then they subtracted a positive 0.002. Now that works in this situation because you do get another 0.003, but it is not always going to work. So there was a lot of confusion about that. I picked the wrong example here. I believe this actually wasn't negative, the 0.005, so then they changed this to a negative when it actually should have been added. I don't know, there are ways where it won't work if you put the absolute bars on the numbers before you use them in calculations. So just make sure that you put the absolute bars on like the final product, the final answer, to make sure you get the correct uncertainty. Another thing is significant figures. So significant figures can be pretty important in your data test if your teacher asks for them. So for me personally, it wasn't included in our data test, and we were told instead how many decimal places we should be rounding to. So our little answer line at the bottom would say like 3 dp. I believe that is the most common way of writing your answers in your physics data test. Again, most of us, we don't use significant figures in the data test, but if your teacher asks for it, or if your teacher has been telling you that you need to do significant figures, then there might be marks there allocated for that. So I definitely recommend asking your teacher straight up, like in the weeks leading up to your data test, like say to her or him, say, do I need to use significant figures in my data test? Will there be marks for that? And usually they can tell you that. Like usually she'll be able to go like, yeah, use your significant figures, or no, it'll tell you how many decimal places. So that's not really a thing that's like cheating, but you can definitely ask if you'll have to use them. Now, if you do need to brush up on your significant figures a bit, because I know that they can be super duper confusing, I will find a pretty good video for you and then link it in the description. Another thing that you do need to do is just make sure that you do understand your linear relationships. So things like the form, the type of variables are R squared. So the form is basically just like, if I believe correctly, if I remember from my statistics, it's really just like positive or negative, and whether like how scattered it actually is. You're not going to have to talk about that. Just making sure you understand your independent and dependent variables. And the most important thing would probably be your R-squared value. But again, I don't believe that they actually really ask about that in the data test. But just keep in mind what your R-squared value is, just in case they ask you to make a conclusion or a judgment based on like how strong this linear relationship is. They might ask something about that. And that's when you should know a little bit about R-squared and what sort of like the general thresholds for that are, what makes something weak or what makes something strong. Now, linearizing things is very, very, very important. So linearizing things will probably be more useful for your chemistry and physics IA2. And that's basically when you take a curved graph and turn it into a linear graph. So I know in my chemistry IA2 for the galvanic cells, I think I did, the equation I used, I can't even remember what it was called, but it was logarithmic. So I graphed it logarithmically, and then I had to linearize it just to make it way easier to analyze all of that. And how you do that is you change what is on the x-axis. Now, you will not have to linearize something in the actual data test because obviously you can't go ahead and make your own graph. But what I do recommend knowing is what do you actually do when you do get a graph that has been linearized, because you likely could be given one that already has been. So I've got an example down here to show you, and this is for gravitational force between two masses at various distances. So based on the formula sheet up here, we are looking at our formula is F is gmmr squared. So that is our formula for gravitational force between two masses at various distances. And they've graphed that. So if they had just graphed F against R, it would have been some funky curvy thing that I don't even know what it would have looked like. However, we have a nice straight line here. So how did they do that? They put 1 over R squared at the bottom. So what we do here is this is how you do a question based on a linearized graph. So we would look at this and we go, okay, so this is our linear graph here. And we know that whenever we see a linear graph, we can say that F is proportional. So F is on the side, so that's the force on the y-axis, and F is proportional to whatever is on the x-axis. So we can do F is proportional to 1 over R squared because we've got a nice linear line here. Cool. Now, how do we turn a proportionality into an equation? We need to add a constant. So I would do F equals, I'm going to make K my constant, K over R squared, because that is F equals K times 1 over R squared. Cool. Now, this might be asking you something like, what are the masses? What is the mass of one of these objects? This might be what the question is asking you. Now, what you would do from here is after you've figured out what the graph is telling you that force is proportional to 1 over radius squared, and then you turn that proportionality into an equation by adding the constant K. Where do we go from here? What do we do? If they're telling me to find the mass of one of these planets, what do I do now? Well, you go back in your formula sheet and you link an equation that looks like the same, basically the same as what you've figured out here to what you've done. So as you can see, F equals gmm r squared over r squared is the same form as this equation here. And we're looking at the same scenario. So we know that these two formulas are linked somehow. So what I would then do is I would set K to equal gmm. So we know now that the slope of this is going to equal gmm because K is the constant, therefore K is the gradient. So the gradient of this, we're just going to go based on the linear trend line. The gradient is 0.0837 equals gmm. Now, say, to answer this question properly, we would need to be given the mass of one of the planets. So let's just say the mass of one of the planets or whatever these two objects are is just 100. I don't know if this is realistic at all. I'm just making this up. So we've got our gradient, we've got our constant here, and sometimes you will have to figure this out yourself by just doing rise over run. So we've got our constant. Now, we find G from the formula book because G is also a constant. I don't remember what that is. And we know that one of the masses is 100. So we multiply by 100, and then we've only got one unknown left, and that is our final mass. So then you would do the algebra and then figure out that final mass there. So that is a really, really common kind of question on the data test, and it is one that a lot of people often get confused about. And it's all about taking a graph that has been linearized and then figuring out what the proportionality is, Then you add in the constant to turn it into an actual equation. And then you need to find a similar formula in your formula book that makes sense in the situation. And then you set the constant to equal whatever is left over in that formula that you haven't dealt with yet, that's not in your proportionality. Now, K, the constant, will always be the gradient. And then typically you will be given enough information to find some unknown in there. So definitely make sure that you are practicing stuff like that. I believe this is Mackerel Cookies on Discord. I think this is something that they uploaded. So yeah, you'll find all of this sort of stuff on the Discord, all these sorts of practice questions. So that is a super duper important skill. It is one that is often worth a lot of marks. Make sure that you have the ability to read a graph, figure out the proportionality, and then match it back to an equation. And I'm giving you a hint here, there are only so many equations where this will actually work. There are only so many situations where you can actually do it. And the big one is definitely this force with the gravitational. You can also do this circular motion one here. There definitely are a couple, and you very likely will get one of these questions. I definitely recommend that you learn how to do this one. You might also get it based on this down here. There's heaps of different ones you could do it, but you only have so many formulas, and they can't ask you a question with a formula that you don't know. So you'll always be able to match it back. Oh, I put the little formula down here. I didn't have to go up. Now, you use that to calculate the unknown values. The other thing that you might need to do is identify the mathematical relationship between variables, which is just what I showed you. You figure out what the graph is telling you, and then you match it back to something on the formula sheet. And something in these graphs is always going to have to be a constant. So masses of something, speed of something, something will have to be a constant, and that constant will equal the gradient most of the time. Sometimes it will be a group of constants like G, M, M here. The other thing that you do with this often is predicting. So once you figure out your equation or you figure out your mass or something like that, they can make you extrapolate the data and predict something in the future. So once you have your equation, say you've figured out the mass and now you've got F equals GMM over R squared, but you've figured out all of your masses, so you know all of the top, and then they give you a specific radius, then you can figure out the force from there. So often that is one last little question tacked on the end. Once you have your equation, you input the given number, and then you pop it in. Now, data tests often, like maths tests, do follow through errors. So say you do get the question up here wrong. So say you get the wrong mass. If you use that mass down here, you likely are not going to get the question wrong because you've shown the teacher that you know what to do. The only reason you got this force wrong is because you got the mass wrong in the previous question, but you did the process completely right and you did know what to do. So usually you would get follow-through error there and you would get all of your marks. The only downside is that if you can't get the previous question, so you can't get the mass in the previous question, like you just can't figure out how to do it, then you won't be able to answer this question down here. Another thing that I've seen done, I don't know if it was on the official data test or on another one, sometimes they might give you something like, if you couldn't solve the last question, in this question, use X equals or mass equals whatever. And they'll give you a random mass number that is incorrect. So it's not the real mass, but it just allows you to do the second question. You can't obviously use that mass that they've given you to work backwards to figure out the other answer because they are going to give you a false one. But they will, usually your teachers are on your side and usually they will try to help you as much as possible to get marks through follow-through error. So don't worry about that. Now, finishing up, there are 3 different categories that questions can fall under, and basically all of these will be assessed in some sort of way using at least some of these dot points. I did want to touch on something that I found that I have not included in this video, and it is all about uncertainty and how we find max and minimum equations and all of that. So if you do want an extra video on that, just let me know and I can make another video showing you how to do that question. So these are our 3 different categories and all of them will be assessed, and the dot points below them are the ways that they can assess them. So the first one is to apply your understanding. So this is the simplest one, and you're usually calculating, determining, identifying, and recognizing. So that includes things like calculating the average or mean from a set of data, calculating a value not using a known formula, so you don't really have to figure out the formula yourself. You're given it or it's in the formula book. Determining missing values from a data table by identifying their relationship in the data. Determining absolute or percentage uncertainty from a set of data, the uncertainty in a mean or the uncertainty in a gradient or intercept in a 3-line regression. So that's what I was talking about before. If you would like to know how to do a 3-line regression, just let me know and I can make another video. Identify an anomaly or an outlier, and identify a value from a graph using one data point. So that's basically just reading off a graph. I do recommend you bring a ruler for your physics data test, because when you find your points on the graph, it's super good to have a ruler. That just reminded me, this is something that my teacher did. I don't know if you guys as teachers do it, so I definitely recommend asking or just doing it anyway. With our rulers, she made us draw when we had to figure out like the gradient or something, and we had to pick 2 points on a graph. Say we got something like that. This is what my teacher would make us do. She'd make us find a point here and a point here. And she would make us get our rulers and actually like draw a line or a dotted line like this to show exactly where we got our X and Y values from. I don't know why she made us do that, but that was like something that she like actually made us do. And she's like, guys, you have to do it. So I don't know if there were marks allocated for that. I don't remember, but that might have just been my teacher, but I definitely recommend checking with your teacher, or to be honest, just doing it anyway. It's not that big of a deal to just do it anyway. But yeah, my teacher was super strict about that. Well, not strict, but she was like, guys, you have to do it, wink, wink. So yeah, that's just something that I always had to do. So if you're identifying points from a graph, you might have to do that, but definitely bring your ruler anyway. Now, the second category of the second category they're assessing you in is a bit of a step up. So we are looking at analyzing evidence. So that's like categorizing, classifying, contrasting, distinguishing, organizing, sequencing, identifying trends, patterns, and relationships, limitations, and uncertainty. Just putting it out there, if you don't know what all of these words here mean, like all of these cognitive verbs, I have a whole video on explaining the cognitive verbs in science. So I will also link that in the description and in the comments. But things in this second category include identifying the relationship between 2 variables in a data table and then using this evidence to support the claim. So you might get something like, oh yes, F is proportional to R. So then you would have to take 2 data points from the table and then stick them in an equation and say, oh, well, yes, as we can tell, F is proportional to R. Or it might say something like F is 1 over R squared. So then you would put in an F value and then you'd put in an R squared value. And if both sides equal, then you've used evidence from the table to support this claim. So usually using evidence from the table is literally just taking a set of points, an X and a Y coordinate, subbing them into the equation, and then if both sides of the equation equal, or at least approximately equal, then they do support the claim. A lot of the time it will be just an approximate equal, but that still should be fine. Identify the relationship from a graph and justify with evidence. Identify factors affecting the shape of the graph, and analyze the data to test a claim. So that's sort of the same as above here. Then the last one is all about interpreting the evidence. So this is definitely the highest cognition. So compare, deduce, extrapolate, infer, justify, predict, draw conclusions, all of that. So you can predict or infer the shape of the graph if the variables change. I haven't seen a lot of that, but it is possible. Compare the gradient of a line of best fit for a linear or linearized graph with maximum and minimum gradients in their y-intercepts. So again, that's that 3-line regression. If you want a video, let me know. Deduce the absolute or percentage uncertainty in the gradient or y-intercept. Same thing as above. Predict values by extrapolation or interpolation. So that's what I was telling you about, how once you have the equation that you've figured out yourself, or you've figured out a constant in it somehow. Once you have that equation, you input a number and then you get your answer. So you can extrapolate or interpolate, predict some sort of value. You can propose the meaning of a gradient in terms of a physical quantity. So sometimes that will mean blah, 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 we've done everything, and then you go, oh, well, this gradient is actually the gravitational constant. This is the meaning of that gradient. So that often means something, or you could draw a conclusion about the magnitude. So that might be for every 1 meter, the distance increases, the force decreases by a quarter. I don't know, making that up. No, that wouldn't be it. For every meter, the distance something, the gradient something. So how you interpret a gradient in statistics, I learned at uni, is for every 1 x variable, every 1 y variable. So for every meter you run, your energy decreases by 100 or something like that. The last one is to determine the percentage and absolute uncertainty in physical quantities derived from the graph. So those are all of the really common question types that you will get. Some are definitely more common than others. I can guarantee you will get like a linearized graph that you will need to find like the force or whatever, like use these sorts of equations to figure out. I can guarantee you'll get one like that. I can guarantee you'll probably get like a 3-line regression thing. There are definitely a couple ones that you probably will very likely get, so I definitely recommend learning how to do those questions. There are billions of resources in the QCE Discord server, so I would definitely hop on there and get those resources. Other than that, I don't have a whole lot more to say. The only thing I could do from here on out is tell you, like, make videos explaining how to do specific question types. So if that's something you're interested in, please let me know and I can get that done for you. Otherwise, I hope you liked this video and I hope it gave you some insights into what your physics IA1 is going to look like. Thank you for watching and please like and subscribe.